Hello guys, welcome back. In this video, we're going to cover the basic concept of Java that is called garbage collection. So this is very simple topic, but little bit confusing. Try to understand and try to follow till the end so that you can able to understand or you can able to get the complete idea about the garbage collection, how it is going to work in Java. So in this video, we're going to cover what is garbage collection and how it is works and what is automatic and what is explicit garbage collection and how we are going to use finalize method in garbage collection along with the real-time examples we are going to discuss in this video. So the basic idea of garbage collection is whenever the memory is going to be filled, that memory has to be freed up. So in general, this is not the new concept. Every programming language is going to have the concept of garbage collection. But the thing is, in other programming language like C, C++, we need to manually we need to perform the garbage collection operation. For example, if we take C, C++, we have a method called free. So with the help of the built-in method called free, we are going to call the garbage collector so that the allocated memory will be released. But in the case of Java, there are two ways where we can do or we can perform the garbage collection manually or automatically. So let us take one simple example. For example, we have a mobile, and in that mobile, we are using one application to edit one photo or image. So what we'll do, we'll edit the image and we'll apply some filters, we'll save it, and we'll check whether that particular image or the modified image is looking nice or not. If not, what we'll do, again we'll apply some more filters, then again we'll check. Like this, the same process will be repeated until we are going to satisfy with the image what we are edited. Or once we satisfied with that image, what we are going to do, we are going to save that image and we are closing that editor. But the thing is, whenever we are closing the editor, whatever the previous edited image or whatever the previous saved images are to be available in the memory itself. We saved the updated one, but what about the previous one? So all the previous images are also along with the objects what we are including in that particular image. So all these objects are available in the memory itself. So now, once we finalize the image, the previous images are not required here, or the objects what we are using in that particular image previously are not required. Now that we'll use the concept of garbage collection. Here, two words we need to remember. One is called garbage collection, and the second one is called garbage collector. So, garbage collection is a process of cleaning the memory, and the garbage collector is like a tool which is used to perform the operation on that particular memory. So, in general, the garbage collection is a process which is automatically or manually freeing up the memory by deleting unwanted objects or the objects which are no longer used in future, that objects we are going to remove. In general, the Java itself perform the automatic garbage collection process, but based on the requirement, manually also we can do that. The basic advantage of this garbage collection is whatever the limited memory, we will see now, whatever the limited memory we have to store the objects, and I want to use that memory very effectively as well as efficiently so that the memory overheading will be removed or memory leaks will be removed so that whatever the memory we have, that memory we are going to use very efficiently. In the same manner, if we consider another example, we have a book shelf here. Let us assume this is book shelf and I'm keeping all the books here. Now, when you are keeping the book one by one, at one particular point of time, this entire shelf is going to be filled up. Now, if you want to keep one more book, there is no place in this particular shelf, for example. What we'll do? We will search in the shelf and the books which are not required for you in future, that particular books has to be removed so that we are going to get some empty space, and in that empty space, we are going to place the new books. In the same manner, the Java is also having the concept of garbage collector like other programming languages. But the beauty of the garbage collection in Java is it will perform automatically. Instead of calling manually every time, garbage collector will be called in regular intervals whenever we need or whenever there is a need of freeing the memory. Whenever we are writing the program, we need to create multiple objects in that corresponding program. So we created some objects here, let us assume that, and we are using that objects. So whenever we are using the object, there is no problem. We have object in the memory and that objects we are using now. So there is no problem. After some time, when whatever the objects we created, among them, some objects we are not using and we are trying to create extra new objects into that memory. So during that process, the garbage collector will check what are the objects which are not used for longest period of time, or whatever the objects which are not referred in the program, that objects are to be removed so that the memory is going to be freed up and that memory we are going to use for another objects. For example, let us assume I am creating an object called data. So string data is equal to new string I am writing hello. Here, I am creating an object called data for the string class, and for the data, we are assigning some value called hello. That means what? We are referring this object here. This object is going to have some value here. So that's why there is the garbage collector will not remove the object called data. Now, for example, I added one more statement here, data equal to null. So when this statement is added, previously the data object will consisting of the string called hello. But now after execution of this statement, the string becomes null here. That means the object data will not have any value. So in this case, the data will be useless here. We can consider this as a unused object or unreferred object, we can say. So this object has to be removed by the Java garbage collector. Now, as we are saying that the Java garbage collection will run automatically, but at what intervals and when this collector is going to be called. As we discussed in this example, immediately the Java garbage collector will not be called. But based on the situation and based on the memory or based on the free space available in that particular memory, the Java is going to call the garbage collector. Now we have JVM, Java Virtual Machine. So the garbage collection process has to be done within the JVM. That is, Java garbage collection is a part of JVM. So inside the JVM, it has to call the garbage collector. So the JVM will decide when to call the garbage collector and when to clean the memory based on the requirement. If you want to clean the memory manually instead of automatically, if you want to clean the memory, then we can also call system.gc. When we call system.gc, gc means garbage collector. So system.gc means we can call from the system class, we are calling the method called gc. So with this line also, we can call the garbage collector. Apart from this, we can also write runtime.getRuntime.gc also we can write. Means whenever you are calling system.gc, it will call in turn the runtime.getRuntime.gc. So anyway, we can write here. Whatever the limited memory we have, that memory I want to use efficiently. For that, either we can use explicit garbage collection or automatic garbage collection. So when the garbage collection has to be implemented, when this garbage collection has to be called, whenever we have unused object, whenever we have unreferenced object, or whenever we have anonymous object, in these three cases, we are going to call the garbage collector either manually or automatically. So we will see these examples here. In these three cases, the garbage collector is going to be called. As I said now, as we discussed in the previous example, employee E equal to new employee E equal to null. So we are creating an object called E for the class employee, and we are also assigning E equal to null. That means what? Whenever we are nulling the reference, whenever we are giving null to the reference, in that case also, we can call garbage collection. In the same manner, for example, I am writing employee E1 is equal to new employee E2 is equal to new employee. That means for the employee class, we created two objects here, E1 and E2. So here I'm writing E1 is equal to E2. That means what? Whatever the content we have in E2, that content will be transferred to E1. That means the reference E2 will be referred to the E1. So in that case, now the first object referred by E1 is available for the garbage collection because the E2 is also referred E1. That means in both the objects we have the same content. So in that case, one object may be useless. So in that case, it is called the garbage collection to remove that corresponding object to free the memory. The third case, by anonymous object. So in the third case, by anonymous object. So for that, if I write new employee, we can call this as anonymous object. In this case also, we can call garbage collection either automatically or manually. Now, how the garbage collection has to be called and what actually happens inside when we call the garbage collector. So what is going to happen inside when we call the garbage collector? In general, it will perform three-step process here. One is called mark, and the second one is called sweep, and the third one is called compact. So let us assume these are the objects here: object 1, object 2, object 3, object 4, and object 5. For simple understanding, try to look at this image. So we have objects here: object 1, 2, 3, and 4, 5. 5 objects are there. Now, so after some time, the garbage collector identifies these two objects are not used. So these two objects are not used in future. There is no reference for these two objects here. So two unused objects are there. So in that case, the garbage collector has to mark. So it is marking these two objects are not used. So these are the two unused objects are there. So for that, the garbage collector has to mark this. Then after, sweep means it has to remove that corresponding objects. So these two objects are removed here. Now we have an empty space here. We are also have an empty space here. Now the third step, the garbage collector will do the process of compacting. That means what? Compacting, arranging the used objects in a specific order. So instead of keeping the used objects in random manner, what it will do, it will arrange all the three objects in a specific manner. That is called compact. So whenever the garbage collector is called, it is going to perform these three steps. First, it will mark the objects which are unused, and the second, it will sweep the memory, it will clean the memory, then arrange all used objects in a specific manner. This three-step process has to be performed whenever we are calling the garbage collector. I hope you got this. Now, so in the garbage collection, we have two generations are there, young generation and old generation. Young generation means the objects which are recently used, and old generation means the objects which are used from long period of time. So this young generation will be divided into two types here, hidden space and survivor space. In hidden space, where the objects are going to be created and new memory is going to be allocated. Survivor space means whenever the memory is going to be freed up in the hidden space, the remaining objects has to be moved to the survivor space. So this survivor space is divided into two parts here. One is called from space and to space. Whatever the memory we have, that memory is going to be divided into multiple parts. One part we can call this as the heap area, and others are stack and meta space. There are multiple spaces are there that are not required for now. So whenever we have heap area, this heap area is going to contain all these memories. Like this heap area will contain young generation and old generation. Young generation will contain hidden space, from space, and to spaces. So whatever the operations performed by the garbage collector in this area will be considered as minor garbage collection, and whatever the operations performed by the garbage collector in this area will be considered as the major garbage collection. In simple words, the minor garbage collection will be done very frequently by the automatic process or the manual process, and major garbage collection will be performed very rarely. It will not perform very frequently. Very rarely, the garbage collection is going to perform major garbage collector. In simple terms, this is to be performed in permanent memory or secondary memory, and this is to be performed in the temporary memory. Let's take one simple example. So this is a basic structure of the memory. We have a heap memory. In general, the objects are created in the heap only, and we have another memory called stack, and we have the third memory called metaspace, where whatever the methods we created, whatever the structures we created, whatever the classes we created, all these structures are going to be stored in metaspace. Now, so in stack, there is no garbage collection is required. In stack, it is not required to perform any garbage collection, because in stack, according to first in first out, the items or the objects are going to be moved from the stack. But in the case of heap, as well as in the case of metaspace, there is a need of performing the garbage collection. So heap is going to have multiple spaces here, hidden space and survivor space, and the survivor space is consisting of two parts again, from space and to space, and which is also consisting of young generation and old generation. Now, try to understand this example very carefully. Now, we have four objects are there. Let us assume object 1, 2, 3, and 4. Four objects are there. Now, let us assume after some time, there are couple of objects which are not used. There are two objects which we are not using in future because of various reasons. The garbage collector will mark the two unused objects here, which are marked in the red color. So that means what? These two objects are unused objects or unreferenced objects or anonymous objects, whatever it may be. So these objects are marked in the first phase. After marking, it has to sweep, because as we know, there are three-step process in the garbage collection. In the first step, mark, and the second step, sweep, and the third step is compact. So first, the objects are to be marked which are unused. Then it has to sweep. It has to delete the objects. Then after deleting, as we can see, one object is placed here and the second object is placed here. So it has to compact. It has to arrange in a specific order. In the third phase, there the garbage collector will perform the compact space like this. And now, so after compacting, what it will do is, remember carefully, After performing the compact operation, whatever the live objects or whatever the objects which are using right now, these two objects has to be moved to any one of these two spaces, either to from space or to space. So whichever is free, these compact objects has to be moved to any one of these two spaces. That is, from hidden space, the objects are moved to survivor space. Now, here two are empty now. From space is empty. There is no object here. Two space is also empty. There is no object here also. So what it will do? These two objects has to be moved to from space. Now the entire hidden space is empty. So in the second cycle, let us assume we have three objects created in our program. Now, after some time, let us assume one object is unused here, so that we mark this object. Then after sweep, it has to delete the memory. It has to delete the object from the memory. Sweep operation is done. Then after compact, so it has to arrange in a specific order. So these two objects are ordered here. Now, so as we discussed in the previous case, whatever the compacted objects or whatever the objects which are in live has to be moved either from space or to space. But now here already we have two objects in the from space. What it will do is the garbage collector will try to place the objects which are in use into a free space. Whichever is free, it will move the objects from hidden space to either from space or to space. Already we have some objects in the from space here. So what it will do? It will move the objects from hidden space to space. But now, whenever it is moving the objects from hidden space to space, these objects also to be moved into the same place. But whenever it is moving from space to space, it will check any objects which are unused, which are anonymous, and which are unreferred. If any one of these three kinds of objects are available in the from space, that objects also removed here. I'm repeating again, listen carefully. Whenever the objects are moving from hidden space to any one of these two spaces, it will check which is free into that particular space. These objects are going to be moved. And here, among these two spaces, the two space is free here. So what it will do? It will move these two objects into two space so that this particular space becomes free. Whenever it is moving from hidden space to space, these objects also it will move from space to space, because it will keep all the objects in one particular location only. When it is moving these objects from space to space, it will check any anonymous or unused or unreferred objects are there. If anything there, that object is to be removed. So just for our understanding, we considered there is one object which is moved from hidden space to from space previous case. So among these two, one object is unused object here, for example. Now what it will do? It will move these two objects into two space, and this object is also moved to two space, and this object will be removed. As you can see, so there are four objects are there, two from hidden space and two from space. But from the from space, one object is unused here, and this is two, and this one. Total three objects will be moved to space. Again, the same thing will be repeated for a couple of times. Whenever we have new object here, and after some time, if any unused objects are there, that will be marked as a that will be marked with the objects which are to be removed. Then swap, then compact, then next time it will be the live object will be moved to from space. So like this, the same iterations are to be performed for multiple times. Next time, for example, next time again another some more objects are created in the hidden space, and after some time, let us assume some objects are unused objects. So it will mark that, it will swap that, it will compact. So now after compact operation, what it has to do? These objects has to be moved to any one of these places. But now this space is not free here, and from space is free, so it will move all the live objects into from space along with these objects. Now all the objects will be placed in the from space. So if any unwanted object is there, that will be removed here, and these objects are also moved to from space. Like this, the same iterations are to be continued. For how many times? For 15 times. As we saw, the first time the objects are placed in the from space. In the second iteration, objects are placed in the to space. Third, from space. Fourth, to space. Like this, these two spaces are alternatively used by the garbage collector. So if any object is live for 15 times, right, for example, whatever the object we created first time, that will be moved to from space first. Then still it is alive, it will be moved to to space. If still alive, again move to from space to space, like this. If any object is moved from space to space to from space, like this 15 cycles, then that object will be moved to old generation. So after 15 iterations, these whatever the live objects we have, that live objects are to be shifted to old generation. Means what? The objects which are using from long time will be considered as the old generation objects. So as every time the objects are shifting from hidden space to survivor space, during that period, the garbage collector is going to called very frequently. But when the objects are moving from survivor space to old generation space, after 15 iterations, if you want to perform the garbage collection in old generation, we should not do the same operation very frequently. Very rarely we are going to perform these kind of operations. So these performing the cleaning process in the old generation will be considered as the major garbage collection process. Performing the cleaning process in the hidden space or the young generation, we can call this as a minor garbage collection. So this is to be done very frequently and this is to be done very rarely. So in general, when we come to the heap space, approximately the area of heap space is just 768 MB only. So very limited space we have. So in 768 MB only, we have hidden space, survivor space, and old generation space. In the case of stack, we have 1024 KB or 1 MB, we can say. So anyway, the garbage collection process is not required in the case of stack. In the case of meta space, we have more space than the heap here. So here also we need to perform the same kind of garbage collection. I hope you understood what is garbage collection. So when we come to types of garbage collectors, there are multiple types of garbage collectors are there. Among them, most used garbage collectors are single garbage collector, parallel garbage collector, concurrent mark sweep collector, garbage first collector, and jet garbage collector, Shenandoah garbage collector. So let us see one by one very quickly. When we come to the single garbage collector, we have only one thread. We can call this as a single threaded environments. So whenever we have single threaded environments, whenever we have small applications, in that case, we can use the single garbage collector. As you can see, these are the symbols to represent the single garbage collector. We have threads are there, but it will collect one by one, right? So when we come to the parallel garbage collector, the name itself suggesting that parallel. So the garbage collection process will be done parallelly. When we are going to use this? When we have multi-threaded applications, when we have high power CPUs, in that cases, we can use the parallel garbage collector. So this parallel garbage collector is going to have multiple threads here, garbage collector threads here. And these threads are focusing on maximizing the application throughput. That's why we can call this as a throughput collector. The third is concurrent mark sweep collector. Whenever we have low pass time, so whenever the garbage collector want to perform the cleaning process in the memory, it will instruct the JVM so that the execution of the program will be halted. After cleaning process, again the execution of the program will be continued. So that's why if you perform very frequently, it will pass the execution of the program also very frequently. So for that, whenever we have low pass time, in that cases we can use the concurrent mark sweep collector. So it will perform most of the work simultaneously, so that will reduce the pass time of that corresponding program. As you can see, this color are the threads and this color is the application. So these are garbage collector threads and these are the application. So the main intention of this collector is to reduce the halt time of reduce the execution halt time of the program. For that, what it will do? Concurrently, it will mark as well as it will sweep. So we can call this as a concurrent mark sweep collector. And the next one is garbage first collector. We perform the garbage collection operation whenever we have huge percentage. For example, whenever we have large applications are there, or whenever we are running large applications with heap larger than 4 MB, in that case we are going to use garbage first collector. For example, if you observe this is the before garbage collection and this is the after garbage collection. If you see, let us assume 1, 2, 10 objects are there, and among them 6 are unused here. So 60% of garbage will be there. And here 10 objects are there. One, 2, 3. 7 objects are unused objects here. We can call this as 70% garbage. And here, among 10 objects, 3 objects are unused. So we can call this as 30% garbage. Among this, the place where the garbage is more, that corresponding memory is going to be freed up first. So here 70% garbage is there, so it will free this entire memory. Then 60% garbage, it will free this entire memory. Like this, whatever the objects we have here, 1, 2, 3, 4, 5, 6, 7. So these objects are placed in survivor space. So like this, whenever we are running the large applications, we are going to use the G1 garbage collector. Same manner, Jet garbage collector and Senando garbage collector, they are not required right now. We'll discuss later. So let us take one simple example to understand the garbage collection process. For example, I am writing class this demo. Then, so I'm writing one method public void finalize. This message I'm printing just whether garbage collector is called or not. For that I'm writing one method called finalize system.out.println. So I'm writing gc called just to show whether the garbage collector is called or not. For that I'm writing this method. Now I'm writing the main method. So here what I will do is, so I will create one object here. Let us assume. So the class name is this demo and object name is s1 equal to new this demo. Then, so I'm calling the garbage collector by writing system.gc. So I'm writing the garbage collector system.gc, or we can also write like this. Whenever we call system.gc, it will in turn call runtime dot get runtime dot gc. It is going to call anyone we can write, no problem here. Now let us run this code. So I'm saving this, then I'm running this code. So when we run this code, nothing was happened here because we created an object here. That object is stored in hidden space. Then we have some reference here. S1 equal to new this demo. We have some reference here. So that's why nothing is called. Garbage collector is not going to call because we have an object here. That object we are using now. So no need of calling any garbage collector. For example, so here I'm writing S1 equal to null. The first case I'm using here means what? Whenever you are assigning null reference to that corresponding object, in that case, the object S1 becomes unused here. We have object S1, but that is referring to null. So there is no use unreferred object we have. The S1 becomes unreferred object. So this has to be called the garbage collector. When we run this code, as you can see, the garbage collector is called. That means what? The object, whatever the memory we have for S1, that memory is going to be freed up. If we take one more object here, this demo S2 equal to new this demo. Now if we consider how many objects are there, 2 objects are there. S1 is referred, S1 is unreferred object now, but S2 is referred object. How many times the garbage collection has to be called? Only one time, because we have one unreferred object. That's why it will call the garbage collector for one time. S1 equal to null. When we run this code, we can see first time the garbage collector is going to be called. Now, here I am writing S1 equal to S2. This code here, again we can see the GC is called. So I hope you got complete idea about what is garbage collection and how it will work in Java. So that's all for now. If you have any queries, comment on me so that I'll try to reply. Thank you. All the best.